Okay, sorry for the delay. Thank you for the opposition. And I'll try to address some issues here, even though, as they said, I have some, let's say, problems with calculations and so on. I probably overreached the capacity there in some points. So hopefully, in this next month, we will do. I'll improve a little bit mathematically and enhance the probability. I'm happy about it. Still, you were convinced that the banks are in trouble, even though it's pretty sure. But the paper probably enhanced the view even more and write the thesis. Well, not write, but read the thesis. That would be that it was comprehensible so far. So I hope to keep up the job, and you motivated me to do that. Well, next I would like to say about your comments. Some of them that you sent to me, some of them that you presented here. And well, it's fair enough that I have to put the description of the banks, as if some people from abroad would read it, then yeah, definitely they would have. Also, about the empirical part, that it includes methodology a little bit, so I have to switch if I read that fully. And about the research question, I have myself, let's say, a creative crisis a little bit now, which because well, the research question stated in the paper is what are the default probabilities of SEB, SCB, and Swedbank. And practically with one model I already explained it, but now I would like to look a little bit at it more and, let's say, try the validity of those probabilities. And for that I'll try to use CDS, implied spreads, and also Monte Carlo simulation as such. I'll probably tell a little bit about Monte Carlo later, because that caused some also misinterpretations, let's say so. And let's move with some problems. Well, inclusion of the other banks, I thought about it, but the thing is that, well, I took these two in particular because they traded in quite liquid markets and they have all the data available. They are really, it's not that it's some local bank in Latvia that is traded on Riga exchange, where you wouldn't get, where you couldn't assume by far that the markets are efficient or something like that, because, well, there is illiquidity and so on, and the data is less accessible. But, well, I mean that some of them, I'll try to put it, I changed the topic before this deadline to the structural, that it would include the Scandinavian banks like such, not particular those two. So I'll try to maybe put Nordea, DNB Nord, or something like that to make it a little bit more different. Maybe also some Lithuanian, Latvian bank that would have the probability of one, hopefully, just to make the rankings better. Then assumption of constant volatility and interest rate structure, yeah. I tried to address that, and there's two ways of addressing. One is quite, let's say, complicated mathematically. You have to get some numbers from the Black and Scholes formula, which it should be done practically. It's pretty hard. Well, my idea of this model would be that someone who have read the paper, or me myself, after I submit the thesis, I could still, put the blog on or something where I could calculate continuous default probabilities. You wake up in the morning, you check the default probability of Swedbank or something. And for this reason, I have to keep it, let's say, in a simple mode that everybody could replicate it and try to calculate maybe with their assumptions. But on the other hand, those assumptions of constant volatility and interest rate structure, well, they will be shifted by Monte Carlo, and this is why I use Monte Carlo, because even though it uses quite a lot of computational power, it's still it's pretty easy to make it and to let's say to forecast with it. So, and quite problematic. Well, new models they become highly, let's say, mathematically complicated, and I wouldn't say that their value added is so much better. Well, so much, let's say, worth the effort, and making the model so complicated that, let's say, it would be hard to calculate the default. And also some, well, you said that you understood that I calculate volatility for the whole period. well, that was not exactly the case. What I did is, for example, this is today, yeah? So for today, I take one thing is, this is default barrier, this would be the stock price. And I take backwards a trailing period of 6 months monthly returns annualized volatility, and I put it in the model. And then I forecast into the future. And this have been done in many papers like that to put it moving, because, well, assuming it to be constant it's a bit bad, but we are assuming it to be constant in the future, but for every single day the volatility changes a little bit, because it's 6 months, so if it includes some crisis or whatever, then it shifts quite, there are even some jumps there. So this would be it, and well, in general I would say that yeah, you gave good comments on the thesis, and good, I mean, some points that I missed out, some points that I left also helped me with the, you know, which parts of text should be in the thesis and how it should be structured. So thank you very much, and I hope that you enjoyed reading. So time for questions probably.